Hey, this is Control Systems lecture for open and closed loop systems for the FE exam. And today we're going to start off talking about what a control system is. Practically every aspect of our day-to-day life is affected less or more by some control system. A bathroom, toilet tank, a refrigerator, air conditioner, automatic iron, a washer, dryer, automobile are all control systems. The requirement of a good control system is accuracy. Accuracy is measurement of tolerance of the instrument and defines the limits of the errors made when the instrument is used in normal operating conditions. Accuracy can be improved by using feedback elements. To increase accuracy of any control system, error detectors should be present in the control system. Sensitivity. Parameters of control system are always changing with change in surrounding conditions, internal disturbance, or any other parameters. This change can be expressed in terms of sensitivity. Any control system should be insensitive to such parameters, but sensitive to input signals only. Noise is an undesired input signal is known as noise. A good control system should be able to reduce the noise effect for better performance. Stability. It is an important characteristic of a control system. For the bounded input signal, the output must be bounded, and if the input is 0, then the output must be 0, then such a control system is said to be stable. Bandwidth. An operating frequency range decides the bandwidth of control system. Bandwidth should be large as possible for frequency response of good control system. Speed is the time taken by a control system to achieve its stable output. A good control system possesses high speed. The transient period for such system is very small. There are two different classes of control systems. There are advantages and disadvantages to both. The two systems are open loop control system and a closed loop control system. And as you can look at the differences, basically the top one, the open loop control system, it goes from the input to a process and to the output. The closed loop control system, you have an input, a summing junction, a process, and then out of the process you have a signal that will also feed back through a sensor and back to the summing junction. And basically that is usually an error, and when it goes back through, it'll come back into the summing junction and it will account for any changes that need to be made to get a better output. Now let's talk about the open loop. It is a control system in which the control action is totally independent of output of the system. Then it is called an open loop control system. Manual control system is also an open loop control system. Advantages: they're simple in construction and design, economical, easy to maintain, generally stable, convenient to use as output is difficult to measure. Disadvantage: they are inaccurate, they are unreliable, any change in output cannot be corrected automatically. Examples: you have traffic control system. This system is based upon a timer and not on the density of traffic. Clothes dryer. Clothes are dried for a certain length of time. Sprinkler system. Water is turned on for a length of time and then shuts off. Now I will say this about the clothes dryer. I know there are newer ones that actually have a detector and will detect the dampness of the clothes. And in that case it would be more like a closed loop. Now let's look at a closed loop. It is a control system in which the output has an effect on the input quantity in such a manner that the input quantity will adjust itself based on the output generated, and it is called a closed loop control system. Open loop control systems can be converted into closed loop control system by providing a feedback. This feedback automatically makes the suitable changes in the output due to external disturbance. In this way, closed loop control system is called automatic control system. Advantages of a closed loop. The closed loop control systems are more accurate even in the presence of nonlinearity. Highly accurate, as any error arising is corrected due to presence of feedback signal. The bandwidth range is large. Facilitates automation. The sensitivity of system may be made small to make system more stable. This system is less affected by noise. The disadvantages: they are costlier, more complicated design, required more maintenance, feedback leads to oscillatory response, overall gain is reduced due to presence of feedback, stability is the major problem, and more care is needed to design a stable closed-loop system. Some examples of closed-loop systems: automatic electric iron. The heating elements are controlled by output temperature of the iron. You set it to, like wool or whatever setting fabric it is, and the heat will adjust according. Servo voltage stabilizer. Voltage controller operates depending upon output voltage of the system. Water level controller. Input water is controlled by water level of the reservoir. Missile launched and auto-tracked by radar. The direction of the missile is controlled by comparing the target and position of the missile. Air conditioner. An air conditioner functions depending upon the temperature of the room. Cooling system in the car operates depending upon the temperature which it controls. Next, we'll look at open loop versus closed loop. This is just a brief summary of kind of what we've already talked about. The open loop control system versus closed loop. You have feedback in the open element is absent. In the closed loop, the feedback element is present. Open loop control system and error detector is not present. Closed loop and error detector is always present. Open loop is stable. Closed loop, it may become unstable. Open loop is easy to construct. Closed is complicated construction. Open loop is economical. Closed loop is costly. Open loop has small bandwidth. Closed loop has large. Open loop is inaccurate. Closed loop is accurate. Open loop requires less maintenance. Closed loop requires more. Open loop is unreliable. Closed loop is reliable. And then a couple examples again. The transfer function. A closed-loop transfer function in the control theory is a mathematical expression describing the net result of the effects of a closed loop on the input signal to the circuits enclosed by the loop. We're not really going to go into the transfer function much, but I thought it was important. If you really want to learn more about the transfer function, we cover that a little bit more in a different lecture. But I did go ahead, and on the next slide you'll see is open loop transfer function, the feed forward transfer function. Anyways, there's 8 different formulas that you can read. Then we have an example problem. A feedback control system or a closed loop system has a forward gain and a negative feedback with a gain of h of z equals 0.1. Draw its block diagram and find the overall transfer function for the system. The block diagram is a simple feedback loop with the specified gains. So basically, if you're looking at it, g of z is the main block, and out of that output signal, if you'll notice, it comes down and goes back, which is why it's called a negative feedback. Basically, that's going to be your disturbance, and it'll go back into a summing junction and then go back and be added to the to the original input signal. So from the formula for loop reduction, the transfer function for the system is y